Good afternoon, ladies and gentlemen. In this video, I'm going to do the preparation problems for practice B of chapter 13. So I made a copy of it here. We're going to get to practice how to do ray diagrams. So you're going to need a straight edge, some sort of straight edge, and the graph paper. I did provide you copies of some optional graph papers you may want to choose to do. All right, so we're doing concave spherical mirrors. All right, so the problem says a concave shaving mirror, maybe you've seen these, probably similar, I'm thinking, to a makeup mirror as well. So it's concave and it has a radius of curvature 25 centimeters. For each of the following cases, find the magnification and determine whether the image formed is real or virtual, upright or inverted. So you're gonna have to make a decision. To make a decision whether it's real or virtual, or upright or inverted, or upside down. Okay, and magnification. Those are the three different things you have to figure out. All right, so it says a curvature of 25 centimeters. So I tried to draw this already for us. It says the radius is 25 centimeters, and the position for part A, it's 45 centimeters from the mirror. 45 centimeters. You do need to draw this to scale. You're doing ray diagrams, and you want to know how to do this because it is on your test. So plus you want to understand how this is. All right, so here's the first thing. If the radius of curvature is 25 centimeters, here's my spherical mirror. I want you to visualize a ball, an actual sphere, where the radius from the center of the sphere to the outside is 25 centimeters. So that would be, here's 10, 20, 25. There's my radius right there. My radius. So it turns out that what you want, though, for the ray diagram and for the equations to figure out where your image is going to be is the focal point. And the focal point is exactly half of the radius. Okay, so I know that the radius is 25 centimeters, and I know that the focal point is 12.5 centimeters. I'm going to go ahead and mark that here. This is 10, this is 12. So right here at 12.5, that's my focal point. All right, so I have an image at 45 centimeters out. Okay, there's 40, there's 45. So I'm going to go ahead and let's say it's a pencil. Doesn't matter, whatever you want to make it. I'm going to make it 3 units tall. Oops, got to be right in the middle. It does help to do this to scale. So it doesn't quite work is because I didn't really draw it. All right, so there's my object. And I'm putting an arrow just to show that's the top of it. And that's exactly at 45. And we call that P. So the question is, where is the image? Okay, so right here, P is 45 centimeters. And F, we discovered, is half of the radius, which is 12.5. So the wonderful equation is that the inverse of where you place your object plus the inverse of where your image is going to be is equal to the inverse of the focal point. Okay, so 1 over P plus 1 over Q is equal to 1 over F. We know what P is and we know what F is. So we want to figure out what 1 over Q is. Before we do that, let's do this graphically because you do need to know how to do it both ways. All right, so here's the story. The way you do it, there's 3 different rays you can do, and where they intersect is where your image is going to be. But you only need two rays. I'm going to do that one first. I'm going to take from the top. Make sure I have my colored pen. I'm going to take it from the top, and we're going to simulate a ray of light, and it's going to go straight. Stand up so I can get it nice and straight. I'm going to go from the top of my image all the way to the mirror, all the way to that mirror. It went in this direction. What happens is from there, it's going to reflect exactly through the focal point, exactly through the focal point. So assuming I'm doing this nicely to scale, here's the focal point. All right. So that ray went straight from the top to the mirror, and it gets reflected back through the focal point. Okay, that's one of them. The other one is a ray of light that goes to the top of the object and goes through the focal point. So I got to make sure I'm getting my marks right here, and it's going to go to the mirror Here, let me see here. I got to get right in the middle. It's kind of tricky to get it right to scale. Oh, something like that. Something like that. All right. Here we go. This one goes through the focal point to the mirror. And from the mirror, it's going to go straight out. Straight out. Here we go. Straight out, back, reflected. Okay, so this ray is going to the focal point and straight out. So let me make sure you can see the different ones. The first one I did was the one from the top to the focal point, through the focal point to the mirror, and then straight back out. Parallel to this one right here is called the principal axis, supposed to be parallel to the principal axis. The next one, see if I can get it nice and light. The next one I did is I went straight parallel to the principal axis first. This is thicker, so I may have to push this ruler down a little further. And then have it go back through the focal point, through the focal point. Okay, so those are my two rays. Now I look and see where they met. And they met right here, below the principal axis. So that is where my image is going to form. I'm going to draw it right there, and it's upside down because it's below. So that's graphically. This is my object, and this is my image. So the image, you'll notice, got smaller or diminished. All right, so now let's do this mathematically, because I can look here and see this is 10, it's about 20 centimeters is where my image is. Okay, so I have 1 over P, I have 1 over plus 1 over Q, and I want to solve for what Q is. What is Q equal to? So I want to solve for 1 over Q. So all I have to do is subtract 1 over P to both sides. So I have 1 over Q is equal to 1 over F minus 1 over P. Subtracted that to both sides. So what do I have here? 1 over F is 1 over 12.5 minus 1 over P, which is 1 over 45. Now, what is that equal to? Here's my calculator. Okay, so we're going to use our inverse function. I'm going to say 12.5. Give me 1 over that. There's 1 over 12.5. And then subtract it. Subtract from it 1 over 45. Okay, that's 1 over Q. I'll write that down. 1 over Q is this big number, 0.05. 7777, etc. But that's not what I want. I want Q. So let's take the inverse of that. So therefore, Q is equal to, with my calculator, I leave it there, and I'm going to say, what's the inverse of that? Give me the inverse. And it gives me a fraction. Tell me what that is. There it is, 17.3. So it says that it's at 17.3 centimeters. That's exactly where it is. Well, as you can see, this isn't exactly perfectly to scale because I'm making it so tiny to be 2 centimeters. We got it about 20. That's kind of close to 17.3. All right, so that is how we got where the image is exactly. Now, we want to know, besides that, we want to know what was the magnification. And M is for magnification. M, magnification. And you find that magnification is equal to negative Q over P. How much does it go up or down? I'm going to say negative. So it's always negative first. All right. So Q, we know, is 17.3. P was 45 centimeters. I'm just going to leave that in my calculator and say divided by 45. And I get 0.3846. So about 0.38 is the magnification. So it actually is 40%. Let's say it's about 40% of what we started. So if it was 3 units, then it's that times 3. I'll say here times 3 units is 1.15. 1.15 exactly. If they gave you how tall it was, I just made up a size. Okay, so there we go. That's my magnification. Now we know that because it's on this side and can actually project it onto a piece of paper, this is called a real image. Remember that virtual images is like what we look at when we're looking in the mirror. It's an image, but it's not real. If you put a piece of paper there, it's not going to be projected onto the paper. And then this is inverted. inverted. So that answers the questions. They want to know where is it, and is it real or virtual, and is it upright or inverted? And there you go. And then the magnification. All right, that was part A. Now let's take that same one, but instead it's going to be at 25 centimeters. Exactly 25 centimeters. So we're going to take the same thing. I'm going to scoot this down a little bit. And let me write down where F is. Let's see, this is 10 here, this is 20. And we said that F is 12.5. So right between these, oh, actually, here's 10, 12.5 right here. So there's F right in the middle. But now it's saying that P, the position's at 25 centimeters. So P is at 25 centimeters. So let's go put something there. This is 20, this is 30. So right here in the middle, I'm going to make it also at 3 units high. Try to make it straight. All right, so this is where we're going to put our P. It's supposed to be at 25. That's P. That's our position. So let's do the same process we did before. We're going to take the top of that and go straight parallel to the principal axis to the lens. Straight. And now we want to go through the focal point, right from that point, right through the focal point. Right through the focal point. I know that I didn't draw the circles perfectly, because if it had, then the middle of the circle would have been exactly at the radius 25, and I did not do that. I took a glass. So not really perfect. So there's the ray. That's one ray. And the other ray, I start at the top and I'm going to go through the focal point. Try that with a different color here. So this ray of light starts at the top, goes through the focal point, hits the spherical mirror, and then right where it hits it, then it gets bounced back. Gets bounced back, reflected. We call it reflected. There we go. There we go. So this one goes towards the mirror, then reflected out. And the other one was parallel to the principal axis first, then through the focal point. And where it meets is where your image is. And I'll take a different color. Or, oh, here it is. Take a different color for where these two lines meet. And lo and behold, it's also at 25, except it's inverted. So let's see if the math works out, because it should work out both way, graphically and mathematically. All right, so we know 1 over P plus 1 over Q is equal to 1 over F. We know that P is 25. We know from before that F is 12.5 centimeters. So we want to know, where is our image, Q? All right, I subtract 1 over P to both sides. I have 1 over Q is 1 over F minus 1 over P. And let's plug that in. 1 over 12.5 minus 1 over 25. That's 1 over Q. Okay, calculator. See what I get. All right, what am I subtracting here? 12.5 inverse of that minus 25. Give me the inverse of that. I have 0.04. All right, that's very nice. That's 0.04, but that's not what I want. I want Q. So please give me the inverse of that. And I get 25. So Q is equal to 25. 25. All right, so now we know exactly that the image is at the same distance as the position of the object. But now I want to know, what's the magnification? Okay, so the magnification is always negative Q over P. And negative Q would be minus 25. And P is 25. So we get negative 1. So that tells us that it's magnified, well, exactly the same size, except it's flipped. Because the negative tells us it's inverted. And it is, in fact. And it's on this side, so we know that it's real. Real. So it's real and inverted and the exact same size of whatever we started with. Okay, so that's what's interesting. If your object is exactly at the radius, which is twice the focal point, then your object reflection, or the image, is going to be also at that same distance, but inverted. All right, let's take C, the last one here for this problem. An upright pencil is 5 centimeters from the mirror. Oh, same thing though. I push my paper down here. And again, here, let's see, this is 10, this is 20. So my focal point is at 12.5, 12.5, somewhere right here. That's my focal point. Now they're saying the object is at 5 centimeters instead. So now we have P is equal to 5 centimeters. So I'm going to put an object, let's see, 2, 4, 6 right here at 5. I'll make it just only 2. I did it before, yeah, 2. All right, so this gets interesting. Notice that when your object is past the focal point, you'll get a real image. When it's right at the radius, you'll get a real image, but not so when you put it when it's less than the focal point. Okay, so this gets a little bit, oh, it's tricky, but not as straightforward. I'm gonna make this guy so you can actually see it. All right, so the first ray I'm going to do is from the focal point straight to the top. And so it's going to be kind of going backwards what we did before, the top. And I'm going to extend it all the way out. All right, okay. Oh, and then from this point here, I'm going to take it back. So I shouldn't have drawn the whole thing. Just to the mirror. And from the mirror, where it hit it, I'm going to go back. There we go. And go back. Now, because it's a mirror, it is also going to go from that side. It's going to get extended. It's going to get extended as well. Well, I'm going to stop it right that one. That's the first one. Okay, the next one is I'm going to go straight from the top to the mirror and then back through the focal point. So that gets interesting. All right, so this one gets straight from the mirror, straight from the top of the object, and then from here I have to go through the focal point. That gets interesting. For the focal point, and then I can extend that one, goes this side, on this side. All right, so that's the other one. And then where's my other one? The other one I'm going to take is from the center, which I did not put here. The center is 25, and that's the other third one I could have done here as well, is take it from the center point, wherever the center point is, 25, and take a ray from the 25 point, and that will also intersect with the exact same spot. All right, so I didn't do it because you only need 2. You can do that on your own. So from here, though, I do need it. So here at 25, I'm going to take that center. I'm going to go straight to through the top of the object from the 25 and go all the way out, all the way out. It turns out where these rays meet, that is where we have our, this one was not correct. Where the other 2 ones meet, that is where we're going to have our image. All right, this one's a little trickier. So this one I'd recommend you really zoom in. It would be a better job. So it looks like it's going to be on the other side, kind of like looking in a mirror. So immediately I know it's virtual. It's not real. It's a virtual image. And notice how it got bigger. Okay, so it's enlarged, but it's also still up. So this one's upright, not inverted. Okay, let's do the math. The math is always easier. This is a little trickier. Okay, so we have, again, F is 12.5 centimeters. All right, so again, 1 over P plus 1 over Q is 1 over the focal point. I want 1 over Q, so 1 over the focal point minus 1 over P. There we go. What do I have here? 1 over 12.5 minus 1 over 5. Let's see what that is. Okay, 12.5 inverse minus 5 inverse. I get negative 0.12. Oh, interesting that it's negative. That's a good clue. That's telling you it's going to be on the other side. Now I need the inverse of that. And I have, comes out to that, and then I got to hit these arrows, and I get negative 8.33. So Q is equal to negative 8.33, or negative 8 1/3. So where did I end up with? 2, 4, 6, 8. Oh, mine is closer to 10. But again, this is not exactly perfect for the sphere. So that also changes things, but it's kind of close. All right, so we know then that Q is actually at 8.33, and the negative means it's on the other side. Okay, let's talk about the magnification. Magnification, we know, is just negative Q over P. We had a negative 8.33, so a negative 8.33 would be a positive 8.33, and the P was 5. Okay, so we take that, divide that by 5, except we know we wanted positive, it's 1.67. So magnification is 1.67 or 1 2/3. So it got bigger by 1 2/3. So we know it's bigger, we know it's virtual, and we know it's upright. All right, so examples here. Make sure you know at least how to do when the object is greater than the focal point. I'm sorry, the object is greater than the focal point, and when the object is between the focal point and the center. That's the two you want to make sure you get to do. I made you a worksheet, what I'm trying to say, a cheat sheet summary of the concave and the convex, and it tells you, hey, it's between these two, it's going to be upright, it's going to be real, and so on. So you might want to refer to that. All right, let's look at the next one. Next one, 35. See if you can see that. That looks better, not much better. I'll make it bigger. Okay, a concave spherical mirror can be used to project an image onto a sheet of paper. I would have done this in the classroom, allowing the magnified image of an illuminated real object to be accurately traced. If you have a concave mirror, okay, they're telling you it's a concave mirror with a focal length of 8.5 centimeters. So immediately I know the focal length, that's F. Where would you place a sheet of paper so the image projected onto it is twice as far as the mirror, from the mirror, as the object is? And then they want to know if it's upright or inverted, and if it's real or if it's virtual. And then they want to know the magnification. All right, so I'm going to write down here, fresh here. All they tell you is that the focal point is 8.5 centimeters. That's what all they tell you. They do tell you it's concave mirror. Okay, so we're just going to do this mathematically without having to draw the, sketch it out. Now they do tell you that they want something twice than the other. What was that? Allowing the magnified of the real object to be traced. Okay, where would you place it? So you want to know what's P. Where would you place it so the image on is twice as far from the mirror as the object? So we know that Q is twice as far as P. So let's go back to our equation. We know 1 over P plus 1 over Q is equal to 1 over F. Well, 1 over F is 1 over 8.5, so that's not a variable. That's an actual number. So we can rewrite this, just replace the Q with 2P, because they said that they want the image to be twice as far. Your concave, where would you place it? The image is twice as far from the mirror as the object is. So that tells you that Q has to be 2 times P. That's Q. All right, so I'm going to just rewrite that. I'm going to have 1 over P plus Q is 2P, so I'm going to say 1 over 2P is equal to 1 over F. Okay, now I want to be able to add it. So I need the denominators to be the same. So why don't I just multiply 2 upstairs here and 2 upstairs there, downstairs there. Okay, same thing. So now I have 2 over 2P plus 1 over 2P is equal to 1 over F. All right, and they have the same denominator. We'll just leave the denominator alone, and we have 2 plus 1, so we have 3 over 2P is 1 over F. Now, 1 over F, I'm going to write on this side, is 1 over 8.5. So I want to solve for P here. Here we go. I have enough. I want to solve for P. Now you can multiply 2P to both sides and multiply 8.5 to both sides, but notice how they're just fractions. I can flip it over, right? Let me give an example. Let's see, 10 over 2 is the same thing as 5 over 1, correct? So isn't 2/10 the same thing as 1/5? 0.2? Yep, it's the same thing. So just for ease, I recognize it and say, oh, I'm just going to flip that. 8.5 is equal to 2P over 3. Good, now I've got the P in the numerator. So I'm going to multiply both sides by 3. And I'm going to have, let's see, 2p is equal to whatever 8.5 times 3 is. Let's see, 8 times 3, 24. 8.5 times 3, 25 and a half. There we go, 25 and a half. Now I need to solve for p, so why don't I divide both sides by 2? Let's divide this by 2, divide it by 2. There we go, 12.75. So I have p is equal to 12.75 centimeters. How did I know it was centimeters? Because they told me the focal length was centimeters. So it's the same units. All right, so there's my p. Now what's my q? I decided that q, well, they told me q has to be 2 times the p. So the q is equal to 2 times that. So times 2 is 25.5. 25.5 centimeters. How about that? So there's my P and my Q. I've got the answers. They want to know where to place, where would I place the sheet so the image is projected. So if I put it exactly at 12.75, then I'll know that my image is twice as much. Let's prove that. What is my, or twice as far rather, twice as far. All right, so now what is my magnification? My magnification is negative Q over P. I'm going to take the Q, so I have negative 25.5 all over 12.75. And yeah, you could round these off, but I don't do that to the very end to keep it accurate. Divided by 12.75, 12.75, and I get 2, exactly 2, negative 2. So negative 2. So I know that it's going to be inverted. So it's inverted. And I also know that it's enlarged, double the size, okay? Now I want you to look at that sheet that I summarized, the convex and the concave, and where your position is relative to your focal length tells you if it's real. So it is a real image. I still use this symbol, but that really is for real numbers, but I still use that for R. It's a real image because the position is greater than the focal length. A little different if it's really, really far. And there you go. So hopefully that's a good refresher for you. I'll hopefully go through this in class too, but please pay attention to how you make your ray diagrams. That's all I have for you guys. So let me know if you want to meet. If you have any more questions for me. All right, take care. See you next time.